One of the most compelling tributes to the spirit of innovation can be found at the visitor complex of the Kennedy Space Center in Florida. Here is displayed the legacy of one country's evolution towards spaceflight. The exploration of space has been the subject of speculation for hundreds of years. In 1640, Bishop John Wilkins wrote, "I do seriously and upon good grounds affirm it possible to make a flying chariot, so that notwithstanding, it is likely enough that there may be a means invented of journeying to the moon, and how happy they shall be that are first successful in the attempt." In the 19th century, Jules Verne wrote his books A Trip to the Moon and Around the Moon, proposing a takeoff from Florida and a splashdown in the Pacific Ocean. With the invention of motion pictures near the beginning of the 20th century, the Lumiere brothers presented their impressions of such a flight. Progress in the field of aviation brought on one of the first major achievements of the space age. In April of 1961, Yuri Gagarin became the first human in space. Only 2 weeks after Gagarin's flight, Alan Shepard also flew above the Earth's atmosphere inside the Freedom 7 Mercury capsule. Later that year, President John F. Kennedy announced to Congress that he believed the U.S. should land at least one person on the moon, followed by a safe return back to Earth, and all by the end of the decade. With this goal established as a national priority, NASA began the Apollo program, which would use a launch vehicle called Saturn V to send 3 astronauts to the moon. This vehicle was longer than a football field, and it weighed more than 6 million pounds. The first stage of Saturn V was equipped with 5 F1 engines. Each engine produced 1.5 million pounds of thrust, and together they could propel the launch vehicle to a speed of 6,000 miles per hour in just 3 minutes. The F1 engines were fueled by a combination of liquid oxygen and kerosene, over 500,000 gallons worth stored in the first stage of the launch vehicle. The second stage of Saturn V used the smaller engine type known as J2. Each J2 engine fired for twice as long as its J1 counterpart on the first stage. A combination of liquid hydrogen and liquid oxygen was used for propellant. The third stage had a single J2 engine that delivered the Apollo spacecraft out of Earth orbit and onto the translunar portion of the journey. The Apollo spacecraft had 3 modules: the service module, the lunar module, and the bright silver-colored command module, which eventually separated from the service module just before entering the Earth's atmosphere and splashing down in the Pacific. A launch escape system was mounted on top of the Apollo spacecraft. Maneuvers in space were accomplished through burns originating from nozzle clusters. Nozzles were mounted on 4 different sides of both of the lunar module and the service module. Since the command and service modules were attached together for most of the trip, their integrated unit was referred to as the Command Service Module, or CSM. About 3 hours after launch, the CSM slowly separated from the third stage, turned around, and returned in order to extract the lunar module from the assembly. Upon reaching moon orbit, 2 of the crew members transferred from the CSM to the lunar module to prepare for descent. The lunar module cockpit consisted of a command station on the left and a pilot station on the right. 7 Apollo missions landed on the moon, and the experience gained from designing Apollo components carried over to the next generation spacecraft. For this next spacecraft, NASA wanted a vehicle that could support a larger crew of astronauts and carry a variety of payloads into space. By beginning to collaborate with other countries, the United States could enhance its spacefaring skills from a global perspective. The next generation vehicle would take on characteristics of the many modern-day aircraft that have helped bring space travel to this point. And so in 1981, the first launch of the Space Shuttle took place. Having the qualities of a rocket during takeoff, a spacecraft beyond Earth's atmosphere, and a glider during its descent for a landing, the Space Shuttle served an important role in the evolution of manned space flight. Will our next step carry us even further than we've gone before? We know the effort and dedication required for such an undertaking. Many people will ask the question, why even bother? Toward this end, the TV and film author Aaron Sorkin once wrote, "Because it's next, because we came out of the cave and we looked over the hill and saw fire, and we crossed the ocean and we pioneered the West, and then we took to the sky." The history of man is hung on the timeline of exploration, and this is what's next.